Good evening, everyone. My name is Kumar Palaniappan. I'm an enterprise architect at NetApp. I'll be going over that architecting business critical enterprise applications, how we architected the big data architecture in NetApp Enterprise. So I'm going to just kind of cover the business challenge, what we had internally, and then the solution, best practices, some of the benchmarking, performance results, obviously the questions. So the project, what we implemented internally using the big data infrastructure is auto support. Auto support is kind of it's an industry standard call home service. What it does is it just catches the issue even before it becomes very critical. It's mainly used for proactive supporting, and it is being used for RMAs without even customer action, so we could even fulfill RMAs. And then obviously that enables the faster incident management. So all our install base sends the kind of a data back to the device health and logs back to our corporate, and then we analyze the data. That's what it is, kind of an industry standard call home service, which is kind of embedded into all our products, which we do that, filers, and they send the data back to our corporate office. It's a humongous data, so each and every file is, so on an average, this payload is somewhere close to 3 to 5 meg. So sometimes some of the configuration performance files are somewhere close to 100 meg either. So why this data is matter to us? This data is being kind of really used by across the enterprise as well as by our partners and customers. This data is being used, so customers, partners, and NetApp. And if you read on the vertical side of it, we use the same data for product planning and development, pre-sales, technical support, obviously, the proactive planning, and product feedback. So I'm not going to read about each and every line over here. In product planning, so obviously the install base management, whatever the product we sell, we really kind of need to manage and support that products. In the pre-sales, we do that kind of a data mining, and then sometimes it can be used for lead generation, but we are not using that use case at this point in time. Obviously in pre-sales what-if scenarios, technical support, end-to-end, automated case generation, if something happens in the field. So there are 3 types of auto support messages which we get. That one is event-based. It can happen anytime. And another one is a daily logs and then weekly logs, which we just kind of retrieve. It's kind of more of a push model to our corporate office. And then proactive planning, we use that for kind of a capacity management and storage efficiency. Obviously the product feedback, all types of metrics, the critical quality metrics, adoption, how our product is being kind of adopted, how it is being used. So all those things, and quality and reliability metrics. This data is being heavily used for all these types of metrics. What are our business challenges? So we do have the system in our enterprise quite some time. It's being there quite, I'm not sure, since I started last year. I believe it's more than some 3-5 years. So it's being there, and it is kind of a really, there are lots of challenges. So this system is getting re-architected every 6 to 9 months due to the growth of the volume of data. So the volume grows, and you will be seeing, I have a slide which talks about how it grows, the data. So every 16 months, it doubles the data what we receive from the install base. Knock on wood, we are doing really good, and we sell more products, and we push a lot of data back to our corporate, and then we start analyzing the data. The challenges are the gateways. So this is pretty dated. So we receive somewhere close to 900,000 ASAPs on a weekly basis, and 40% comes over the weekend, so which I talked about the weekly logs. 40% of that 900 ASAPs, each and every ASAP message, when I say ASAP, it is an auto support. So that message, each message is on an average is 3 to 5 meg in size. Some could be somewhere close to 50 to 100 meg either. And 40% comes over the weekend, and then we see the growth every week 0.5% of this data. Since we are introducing more and more functionality and more product lines, so we gather more data. That's one of the challenge in the gateway side. And then our ETL side, we have a very strict SLA. We need to really let the downstream to consume this data, or the field people, the users need to consume this data within 15 minutes. It's really a kind of a tighter SLA which we have that. The another challenge is we do have the kind of a legacy enterprise data warehousing system. So those systems, only we could able to store 5% of the data what we gather. And the rest of the data is completely unstructured. And we have no means of storing that data. And then this data is growing. As you see that, it grows every month 6 to 8 terabytes in an enterprise. And we have Oracle DBMS as a kind of a data warehousing solution. And we were facing a lot of challenges in terms of patch maintenance, scale out, and then backups, all those things and all. So there is no easy way to just kind of really access this unstructured data which we gather from the field. So that's the great challenge which we had with our legacy. Right now it's operationalized with our old enterprise data warehousing systems. Obviously the reporting, we couldn't able to just fulfill a lot of numerous requests which comes from the field and business users and all. So we struggle a lot. There are ways, but it's a very tedious and manual ways to just kind of pull the data. It takes hours and days and months to just kind of extract the data. And so we all know that there are a lot of untapped potential information which we are not able to just support our field users and our customers, the business users. These are the current challenges at this point in time. So, and as I said, finally the incoming load doubles every 16 months. So the data just grows and grows and grows. We are close to, right now, we are close to 900 to 1 petabyte at this point in time. 900 to 1 petabyte. And the cost model, if you see that every 16 months the data is just kind of doubling, and then we will be seeing somewhere close to 3 to 5 petabytes in close to 2 to 3 years. So that's a growth projection what we are predicting. And in order to support this legacy enterprise data warehousing system, we spend a huge lot of money. The cost, if you see that, how much we spend just to manage this infrastructure and all those things and all. That's another key factor to just really look at different things. So, and moreover, there are lots of new functionality which is being requested by the business. And if you look at it, the latency with the kind of a size of the data. So as soon as within seconds, we need to able to do a kind of a self-service model. And as and when the data grows and then the time goes by, proactive support, and then cross-sell and upsell, performance planning, product analysis, customer intelligence, so many features which is being requested by the enterprise, which we were not able to fulfill with our enterprise data warehousing system. So these are the things which we were facing in our enterprise as a challenge. So I talked about the business kind of a challenge. I'll go over the solution architecture. This is a kind of an ecosystem what we just kind of architected for us. And so pretty much everything is open source, and then we use a Cloudera distro. So we use Flume for the ingest, and then we store the raw files into HDFS, and then from there we parse the data and then just kind of dedupe some of the parsed data, store it into the config for the low latency, store it into HBase for the low latency access, which is kind of requested by the end users, which serves to the external users, the tools, which you see that it is being exposed as a REST API to the tools. And then the analytics is being fulfilled by Hive, Pig, and then we do write MapReduce. So this is pretty much the kind of a ecosystem architecture. I'll go over the kind of a holistic architecture. This is the solution architecture which we put together to just kind of support this. auto support system. So it's basically the Hadoop core is a data platform which we are building right now, re-architecting. So over here, if you look at it, the ASAPs over here, it's auto support messages, which we receive through the front end. There are two protocols. One is a kind of a mailer daemon, and another one is a HTTP protocol. We receive them so from our install base, and then we push the data. We ingest the data using the Flume collector, Flume. So I'll talk about that in later. So into the HDFS, and then from there we further parse and load the data into HBase for a low latency access. I'll talk all those details in the coming slides. So the data services is being created in order to just govern the ecosystem, the platform. We really don't want anybody to just kind of put a hook on their own and then just kind of start taking the data and then lose the integrity of the data. So we created the data services, as well as we created a kind of a ETL service also, where we use Pentaho, and then it just kind of extracts the data out of HBase and HDFS, and then kind of serves to the downstream systems, which are decision support system, DSS, and EBI, all the rest of the external apps. On this side, you see that all the client apps, in the sense, all the external facing or partner, the customer side, or our own external facing apps, they all extract the data through data services layer, which is being exposed as a REST API. And there are a lot of other supporting systems, which is ASAP reliability, which you see that really for kind of a retransmitting if any of the messages which is not being ingested into the Hadoop. So that's all kind of a supporting system which we use that. It's a complete architecture, solution architecture. So it's server agnostic, and then I'll be talking over how our physical footprint and what is the NetApp uniqueness in this whole solution architecture. And there is one more piece also. So how do we really let the end users, the business user, to just kind of extract the data directly for analytical purpose? So you see that report and analysis tool. Right now we are in the evaluation time. We are kind of evaluating a couple of tools at this point in time to just kind of extract the data. So that's why you see that kind of a white box. We haven't yet really finalized which product it is going to be. For ETL, we use Pentaho. The Hadoop is Cloudera distro. We use CDH3 U3. Yeah. So so rest all. So I'll be talking over the E2600 is our unique signature storage device, array-based, which I will be going over that. RX300 and RX200 is a kind of a Fujitsu server, which we have that 12 core. The name node is 72 gig, and then the data nodes are 64 gig, if I remember right. So the data ingestion, I'll talk about the ingestion, so how we do ingest. So we use the Flume. So I did talk about that Flume. Flume is the Flume agents. We use 4 agents, which is responsible to just kind of listening to the spool directories. And then they just kind of, so then what it does, it just listens to that spool directories, and then it is responsible to just kind of dissect that ASAP sectioning into individual records, and then store it into the HDFS by means of using the collector. In HDFS, we go by granularity of minutes. The reason is we do have kind of a tight SLA, so we need to just kind of store it by a minute. That's one thing. So that's what you see that. And then we use, secondly, so it's a kind of a snappy compressed JSON file format. Arrival time bucketing by minute, that's what it is. So I talked about it. And there are some challenges which we faced with Flume. Right now we are kind of experimenting, evaluating with the Flume next gen, and ingesting 4.5 terabyte uncompressed data, 4.5 terabyte uncompressed data using this Flume. So that's what we are doing it. Then apart from that, so we plan to move to Zookeeper in our next release. Right now we are using the Supervisor D, the basic process control. The data transformation, so the ingested data processed every 1 minute. That's what, so since we have an SLA, so we just store it by minute granularity, and then ingested data will be processed every 1 minute, and it relies on the fast scheduler to meet the SLA. So that's what we are using. We used Uzi in the past. Now we are moving to the Pentaho PDI, product data integration for scheduling in our coming release. So that's what it is going to be, the scheduler. So there are two types of files which so I did not talk about that. One is a config. You have seen that over here. So the log and performance and raw config. The log and performance, the config file and then the logs. These are the two big files which we then we just take the config files into the HBase for low latency access. Oops, sorry. Yeah, so the configuration data, how it is being ingested into this HBase. So what we do that is, there are a couple of data loaders which we do that. One is a config loader and another one is a log loader. It's a EMS log, event management system log. So these are the two loader files which we have. That the config loader is really, what it does is it's a streaming job. Config loader is a streaming job ingestion, and so when the map side of it is a kind of an existing Perl code which we are using it to just kind of really structure the data structures, and then on the reduce side of it we use the Java file to assemble them back, and then just kind of assemble that data which is being sectioned or partition, created as an individual record, and then put it into HBase as a Avro serialized format data. The Avro serialized format data, so the reason for Avro serialized format data, and then we have a Solar in the mix. So the Solar is really used for, we use the HBase queue table. There is a table called, we created a kind of a queue table in an HBase to just really update the indexes of the Solar, so to keep them updated, to keep them currently updated. So that's one thing. And then duplicate data written to HDFS as Hive. So the duplicate data in the sense, so we have the log file also, the log, all the logs, which sends all the map reduced files, which just kind of goes into that. It just kind of does some deduping, and then it just emits the kind of a Hive structured format. It emits the data and then puts it into the structured for Hive data. And secondly, we have, so then what else other than that? So I'll move on to that. Clicker not working. Oh, okay. Yeah, the low latency data access. The low latency data access, we are just kind of using three things in the mix. One is the HBase, another one is Solar, and the third one is Avro. Avro is a kind of a format. So Solar is used to just index. So high performance REST lookups, as I said, we just expose the REST API for the external users so that they can just kind of send the query. And then once the query gets executed on Solar, it just kind of brings up the row IDs. And then the row IDs are used to just kind of bring the data from the HBase. If and when needed, then it just pulls the data from the Solar. That's what it uses. Then details pulled out from HBase. So right now we have hundreds, I think 100 HBase regions. Each of them is 500 gig. And it's a snappy compressed files. So we are using a snappy codec. There is a disadvantage of Solar at this point in time is, so we have to literally use the business hash, in the sense the business key mod, in order to keep the files updated if and when there is a file added or the document added. So that's not really scalable. So we really kind of looking at, since solar is not distributed, so we are looking into just kind of using the H-based coprocessor to move forward to keep the indexes up to date. And the fourth aspect of it, we do have an existing BI, so we still need to just kind of give the data back to that existing BI tools and all. The decision support system, so that's an Oracle star schema. We use a tool called Pentaho, which just pulls the data from HDFS and HBase, and then it just kind of dumps it into the star schema. And there are a couple of interesting things, how the load is. The daily export, it's close to 530 million rows. It's a pretty heavy load on a peak day. So that's why you see that our physical footprint is so beefed up. We run that Pentago on 2 VMs, 64 gig RAM and 12 core. So obviously it enables all the existing BI tools to just kind of query the DSS data. DR. So at this point in time, we don't have the DR up and running, but this is what we planned. This will be going in production probably by end of this year. So this is a thought process which we put together, and the DR cluster will be a 75% footprint of the original cluster, and the HBase is kind of backed up incrementally. The Flume is active back, and we thought we can use. So right now we have 4 instances: development, test, QA, test and QA, and then UTB and then stage, I believe, and then production. So we thought we can use the UTB for the DR, but on stage and UTB, not UTB, it's a staging. Staging is very frequently used for a lot of engineering tests. We thought it's not operationally viable and very expensive to use for DR, so that's the reason we are just building a 75% footprint of the production capacity for a DR cluster. All right, so there are key 3 drivers. So when we just kind of started looking into this solution, so the 3 key drivers are cost, performance, and enterprise robustness, in the sense enterprise class. So performance, obviously we need to just kind of really get a kind of a fast response and ad hoc query and real-time queries. We supposed to support all those things and all. And the performance, obviously right now the Hadoop world really dictates you have to have by default it's a 3 rep count. Replication factor is 3. So but here I will be going over one solution which NetApp had come up with. So that talks about we just really reduce that replication count from 3 to 2 since we use our enterprise class storage. I'll go over that physical footprint. And the cost is so if what we are going to just really achieve by just kind of decoupling the storage. Okay, so am I going to add more and more since we are not using any of the commodity hardware over here, and we are using an enterprise class? The reason is enterprise classes, when you are, I don't know how many of you attended the previous session from Walmart. In enterprise, HA, security, all these things are all very key. High availability. High availability means I can't afford to just lose the data. I can't afford to have a kind of a downtime. It's a very business critical application. So how are we going to just handle that? So I don't have the manpower to rebuild that cluster for hours and days. So I really need to just turn that operation up and running within minutes. So that's what we really mitigated by engineering with our own solutions. So it's called NetApp NetApp Open Solution for Hadoop. This is the physical footprint. You can see that MapReduce, and then there is a name node, secondary name node, which is connected to one of our filer, which is fast using 1 gig over NFS. Sorry. And then there are 4 data nodes. Each data node has got only kind of a compute server, not any storage. We decouple that, and then we just kind of connecting the one of our signature product, which is called E-Series, E2600, over here 2660. Each 4 data node is connected to one E-series. That E-series box is it's a 120 terabyte. It's a 5 trays, 60 disk. It could be either 2 terabyte or 3 terabyte in sizes. So it's a fully serviceable storage system. And then, so the beauty of this storage is we did that with a kind of a JBots also in our lab. And we did that with the E-series storage also. The beauty of this is the usable storage of this E-series is more compared to the JBots. That really brings down your cost. And then by bringing down the rep count from 3 to 2, that brings down your cost. So from 3x to 2. And moreover, if you are taking it to the enterprise, obviously the data need to be protected. The data need to be really kind of, they look at all the security. They can't afford to lose the data of enterprise data. Data is an asset to the enterprise. So how we are just really mitigating it? It's a RAID protected data. Currently in this solution, we are using RAID 6. Our next version is going to be RAID 5. Am I correct? Yeah, so RAID 5, we are just kind of recommending RAID 5. Right now, we are using RAID 6. Yeah, with the XFS. This one is the file system is ext3, which is being recommended by Hadoop World. So by reducing the rep count, I really want to bring one point is we reduce the network congestion. So instead of making 3 hops, we do only 2 hops. So why we are doing 2 hops and 2 rep count? Because the data is secured and protected by means of RAID. Oops. So those are the things. And then the third point is the beauty of this E-series is it comes with a kind of a centricity controller, the storage. I don't know how many of you guys knows that, but the controller really gives you the monitoring of all the nodes. If even one disk goes down in the data node, 4 data nodes are connected to one box. Even if one disk in that goes down, so my operation is not disturbed. My operation is not interrupted or it doesn't go down. I'm always up and there serving all the queries and everything and all. That's the beauty of it. And also I can figure out which disk really went bad. So I can just go and swap that disk and then just put the new disk. That's the beauty of this E-series. So the physical footprint, so it's obviously it's a 10 gig switch between the MapReduce, the name node and the data nodes. And we use a SAS cable from our compute server to the storage. It's a 6 gig SAS direct connect. It's a direct server attached only, server attached storage. It's no means of SAN or NAS or anything and all. It's still direct attached storage. We are not jeopardizing any of our performance. The performance benchmarking came up really beyond the bar. So it just blew our mind. So I can just kind of really share some of the numbers. So you guys can just really ask, right now it's a 4 data nodes connected to one E-series. If I increase the data nodes, can I just kind of scale linearly? Yes, we saw that. So the linear throughput scaling, this is what it is. So if we can just kind of keep increasing 8 data nodes to one E-series, we can still kind of really meet the performance. So the takeaways. So it's a Hadoop-based big data infrastructure. So obviously it's cost effective compared to what we were having with the enterprise data warehouse, and a lot of low latency data access to the data. We could able to just really find the ad hoc issues and pattern detection. We are planning to build a predictive modeling using our own innovative Hadoop storage technology, which is called NAS, NetApp Open Solution for Hadoop. It's a great enterprise transformation. That's it. Any questions?
A quick question. You mentioned you were using RAID.
Yes.
And then at the same time, at software level, you don't have to replicate so many copies. You only have 2. 2. So 2 related questions. One is for RAID, which RAID you're using? The second one, in a small configuration, like you mentioned here, can they just don't make replication at all at the software level, and it rely on the hardware RAID capability for HA?
Yeah, so right now we are using RAID 5, RAID 6, and RAID 5 is in our next solution, so which we are just kind of came out, I believe, a month back. RAID 5 is kind of recommended on XFS file system. This is RAID 6 on ext3. So there is a work in the labs which I may not be able to talk, so no replication at all. Yeah. Recover.
The rationale for having two copies is not because you're going to lose the file system on the storage. It's because you could lose your data nodes that's connected to that file system. If that file system isn't shared, it's a SAS connection, so it's serial attached storage. It's owned by that data node. If that data node goes dead, then whatever file system was attached to it is also gone. So therefore, you have to have a rep counter 2 for death of the data node.
Gotcha.
Death of the file system. The file system is still up and running and permanent, but it's the access to it.
Gotcha. Thanks.
Yes. Yeah.
So what is the I/O bandwidth of your storage device compared to this?
6 gig. Yeah.
Per channel, and there are 4 channels. You can go up to 8 channels.
Yes. Is there a question?
So if you set rep count equal to 2, how do you know it's not going to end up on the same node and same quad of the nodes, or that it's going to end up on a different rack, so you don't have to worry about rack switch?
So it's a great question. Yeah.
And so actually, the way you do it, instead of having rack awareness, you actually have 2660 awareness. So you mitigate that by making sure that you're not going to be inside the same physical 2660. So you're not even on the other controller in there. You're physically on a different 2660.
How does Hadoop know about that?
You modify the rack awareness script so that it's aware of that. So there's some, it's a script. It's text editable and textable. You can make that awareness, and it's just part of the best practice when you stand it up.
Okay.
Any
security considerations with the data that you load into the
Yeah, so right now we are just kind of controlling with the user access. So Kerberos comes with the Cloudera distro, but yeah.
There is one other feature we get with the 2660 in our drives.
Drives, yeah.
And we also can support full drive encryption.
Encryption.
So if you have, for example, in healthcare, if you're doing something where you care about the data,
HIPAA
whether
compliance.
it's readable on those drives, if you lose it or something, all of these drives support full data encryption at 0 penalty for reading and writing because it's built into the drive. It's just a license feature.
Yes.
So if I configure the system with your storage instead of just down to JBoss, at the end, what is the cost?
Yeah, so we did that benchmarking with the JBOD and the E-series. So the I/O throughput. So we did a test DFS I/O. So the I/O throughput was, the read was beyond expectation in the sense. So we could able to see 135% more than what we are seeing it with JBODs. The write is at par. So it's close to 1.6 gig per second. The read was 3 to 3.5. On an average, gig per second, compared to the JBOD. On the same kind of a 10-node cluster, just kind of, we created a 10-node cluster, with a JBOD and 10-node cluster with our E-series storage.
From a TCO perspective, for comparison for white box to enterprise class, well, clearly there is some cost difference, but it's mitigated because you don't need to replicate as much. Yeah, with that into account, it's about par.
Yeah, so there is a TCO calculation. So yeah, definitely we can. So do you want to just kind of comment on it, Brian?
There is a report published by ESG on route
The takeaway should be that compared to white box, the total cost of operation in this architecture is substantially cheaper.
Yeah, the TCO is kind of a 3 to 5 years down the line, actually. So the initial implementation might be the TCO in the sense, yeah, the capex and opex plays around, and yeah, the psychology of the Hadoop guys are Yeah, so, yeah, that's right, yeah.
Even the first two
Once you,
reports aren't close to being on par. So
yeah.
it's a very, very good solution.
Any other questions?
You mentioned deduplication earlier. So are you deduplicating just the metadata node, or are you deduplicating data too?
Deduping the metadata, yeah. The flu misuse, I don't have it on top of my head. I wasn't really kind of in that. So we had a couple of issues. One is, so I think it got worked out with the Cloudera. I don't remember right now, yeah. So that's why we started the next gen. Yeah, so we had so many issues with the Woozy, a lot of unknown issues. We couldn't able to debug a lot, and then there are a lot of scalability also. When we start growing up, we couldn't able to really support that. The unknown issues are really kind of ghost errors. We don't know how those jobs are really kind of scheduled, what are those jobs and all those things and all. So that we really kind of avoided by moving to the Pentaho scheduler, which is part of the enterprise suite. So we thought we will use that Pentaho. Yeah. Any more?